To notes 4. So today we're going to talk about solving systems by elimination. So this is really the same type of thing that we were doing in the previous notes, except it's just a different method of doing it. We're still trying to figure out what x and y are when we're given two equations. So let's take a look at our steps. Step number 1 is to put both equations into standard form. Okay, so we're going to start by putting both equations in standard form. Then for step number 2, we're going to multiply one or both of the equations by a number so that the coefficients of the variable so that the variables have opposite coefficients. Now coefficients are the numbers that are being multiplied outside of the variable. Okay, so we're going to figure out a way to get them to be opposites. Next, for number 3, we're going to add the two equations together. Now, when we add them together, when we add down the columns, we're adding like terms. So x's with x's, y's with y's, and so forth. And if we did it right, one of the two variables are going to cancel. That's ultimately our goal, is to cancel one of the variables so that we can go about solving the problem. Taking a look at number 4, we want to solve for the remaining variable. Since we only have one left, we can use what we know about solving equations to go ahead and go through that. For step number 5, we're going to substitute that value into one of the equations and solve for the other variable. So just like we did before with substitution, we're going to plug it back in and we're going to solve the equation. Now both of these methods will work for any type of system. For your homework or your practice for this note sheet, I will require that you use elimination, but there will be spots on your assessments that require you to excuse me, use either method or one or the other. So let's take a look at infinitely many solutions. So if both variables cancel and what's left is a true statement, then it has infinitely many solutions. This is the same as substitution. Same thing with no solution. If both the variables cancel and what is left is a false statement, then the system has no solutions. Alright, so let's just take a look at this. So what we said in our first step is that we want to have opposite coefficients. So I want to have the same coefficient but with the opposite sign. So I see right here that these x's, both of them have a coefficient of 1. Well, that's a good start because they both have a coefficient of 1. So what I want to do next is I want to make one of them opposite. I want one of them to be negative. So what I'm going to do is I'm going to take this entire second equation and I'm going to multiply it by -1. So that means I'm going to distribute to each of those terms following. So we have x plus 2y is equal to 10. Now I want to multiply to each of those. So -x plus -y is equal to -6. So now I have my x's lined up in the same columns, my y lined up in the same columns, and my constants. So I can go ahead and I can add down. Now this only works, elimination only works if your equations are in standard form. X's and y's are on the same side, numbers are on the other. So x minus x is 0, 2y minus y is just y, 10 minus 6 is 4. So that worked out nicely for us. When we added them together, we didn't have to do any more solving. It was already solved for us. So now I know that y is equal to 4. So now I can take any equation. I could take this one, this one, this one, this one. It doesn't matter. I can plug it into any one I want. I'm going to plug it into this one. So I'm going to write x, and then I took the y out, and now I'm going to write in 4. I know y is equal to 4, so I can go ahead and put that in. Is equal to 6. So now I'm going to subtract 4 from both sides. And I get that x is equal to 2. So next thing we want to do is let's take a look at number 2. So again, I notice that these y's have the same coefficient. They have a coefficient of 1. So I'm going to go ahead and I'm going to take this one and I'm going to make it negative. It doesn't matter which one you choose to make negative. I'm going to make that one negative. So then I have negative 2x plus y is equal to 4. And I'm going to keep that second equation the same. Oops, I forgot to distribute the negative to everything. So I need to make this negative here as well as a -4 because I'm taking that -1 and distributing it to each thing. So 3x minus 2x is going to give you x. Y minus y is going to cancel out. -4 plus 8 is going to give you 4. So again, here I have everything solved. X is equal to 4. So I'm done with x. Now I can go and solve for y. I'm just going to choose this one just for something different. So we have 3x, and now instead of writing y, I'm going to write 4 is equal to 8. Okay? So 3x plus 4 is equal to 8. So now what I'm going to do is I'm going to go ahead and solve this equation. So I'm going to go ahead and subtract 4 from both sides, and then I get that 3x is equal to 4. So then what I'm going to do is I'm going to go ahead and divide both sides by 3, and that gives me that x is equal to 4/3. So what I want to do, and I forgot to do on this one, is to write it out as a coordinate point, 2, 4. And then I want to go ahead and write this one out as a coordinate point. Come on. So I'm going to write that as a coordinate point. My x is 4. Oh, I know what I did wrong. I plugged it in for y. So you guys are all probably watching and wondering. So I need to plug that in for x. So x is equal to 4, and then I'm solving for y. There we go. So then I have 12 plus y is equal to 8. Subtract 12 from both sides, and I get that y is equal to a negative 4. So then I want to write that out as a coordinate point, x, and then my y. So my answer is 4, negative 4. Let's take a look at number 3. So for number 3, I noticed that my x's have the same coefficients. I have 2 and I have 2. Okay, so I want to make one of them opposite. So I'm going to take this one right here, and I'm going to multiply it by a negative 1. So that gives me negative 2x. This is when I distribute that negative in, this is going to become a positive 3y, and then I'm going to get negative 11. This is going to stay the same. And now I'm going to add down my columns. Negative 2x plus 2x is going to cancel. 3y plus 2y is going to give me 5y. And then negative 11 plus 6 is going to give me negative 5. So now I want to go through and I want to solve that for y. So I'm going to divide both sides by 5. And y is equal to negative 1. So now I want to go ahead and I want to plug in for one of these y's to solve for x. So I'm going to choose the second equation. It doesn't matter which one you choose. So I have 2x. Now instead of y, I'm going to put negative 1 is equal to 6. So then 2x minus 2 is equal to 6. So I'm going to add 2 to both sides. Okay, so we have 2x plus 2y is equal to 6. So then I'm going to go ahead and plug that in. So I get 2x is equal to 8. Divide both sides by 2. And I get that x is equal to 4. So writing out my coordinate point, I have 4, negative 1 as my final solution. So then I want you guys to take a look at number 4 on your own. What I want you to notice is y is already same coefficient, opposite signs. So you don't have to do any multiplying at all. You can actually just go and add it together right now. Let's take a look at number 5. So for number 5, before we can start, we have to get it in standard form. So I need to add y to both sides on this one. So then I'm going to go ahead and I'm going to get 6x plus 3y is equal to 12. And then I'm going to get 2x plus y is equal to 8. So what I notice on this one is I actually don't have the same coefficient. Okay, I don't have the same coefficient for this one. So what I need to do is I need to multiply one of these. So I notice that this has a positive coefficient of 1. So somehow I want to take 1 and get it to a negative 3 because I want it to be opposite. So I'm going to take this and I'm going to multiply this by a negative 3. So then I get 6x plus 3y is equal to 12. Now 2 times negative 3 is negative 6. Then we get negative 3y, and 8 times negative 3 is negative 24. So what's going to happen is when I add these together, everything on this side is going to cancel. And on this side, I'm left with negative 12. So I'm left with 0 is equal to negative 12. Well, that's not a true statement. So this right here, because what is left over is not a true statement, this has no solution. Let's take a look at this one. So what I want to do is I want to first get rid of all of these fractions. Okay, so I want to ask myself, okay, how can I take 1/3 and get it to be a -2. So that's kind of confusing. But what's even easier is to look at, okay, here's a +1 for a coefficient. So how can I take that +1 and make it a -6? Because we want it to be opposite. Well, to do that, I just multiply by a -6. So I'm going to keep that first equation the same, and I'm going to multiply the second one by a -6. So -6 times 1/3, that's the same as dividing by 3, is a -2x. Then this is going to be a -6y, and then 7/3 times a -6. Well, look at it this way. -6 divided by 3 is -2. -2 times 7 is a -14. So we're going to add down the columns. So we get 0 plus 0 is equal to 0. So we get 0 is equal to 0. So we have infinitely many solutions because what's left over is a true statement. All right, let's take a look at this one. Dante spent $11.25 on 3 new and 4 old comic books. So I'm going to let X equal the new comic books, and I'm going to let Y represent the old. So he did 3 new at the X price, so we're talking about money here, and he did 4 old at the Y price, and it was $11.25. Then it says he spent $15.75 on 10 old, so 10 Y, and 3 new, and that was equal to $15.75. So now we need to go ahead, oops, this should be X right here. We need to go ahead and we want to solve this by elimination because it's already in standard form. Well, I notice here that I have the same coefficients. So what I'm going to do is I'm going to take this second equation and I'm going to multiply it by a -1. So that gives me the top equation staying the same. And then we're going to change the bottom equation. We're going to change all of it to be negative. So then we're going to go ahead and we're going to add down. Those cancel for X. 4y minus 10y is -6y. And then 11.25 minus 15.75 gives us -4.5. So we're going to divide both sides by -6. And that gives us, so 4.5 divided by 6 gives us 75 cents. So we know that old comic books are going to be 75 cents. So let's figure out what new ones are going to cost. So I'm going to plug it into this equation right here. I'm going to plug in 75 cents for Y. So I have 3x plus 4 times 0.75 is going to be equal to 11.25. So then here we get 3x plus 3 is equal to 11.25. So then we're going to subtract 3 from both sides, and we get 3x is equal to 11.25 minus 3, and that's going to give us 8.25. Divide both sides by 3, and I get that x is equal to 275. So it's 275 for new, and it's 75 cents for old. Okay, let's take a look at this one. The sum of two numbers is 12. So we know that x plus y is equal to 12. The difference of the same two numbers is -4. X minus y is equal to -4. Well, this one we can go ahead and just add down the columns because it's already opposite. So we get 2x is equal to 8. Divide both sides by 2, and we get that x is equal to 4. So now we want to go ahead and plug stuff in for y, or for x. So I get that 4 plus y is equal to 12. Subtract 4 from both sides, and we get that y is equal to -8. So let's get this one set up. So we want to figure out when they're going to cross the same point. So we're going to go ahead and set this up. So we want to figure out when x and y are, that they cross. So for this one, you're going to have to bring the x over to the other side. So that's going to give you a -6x plus 3y is equal to 6. So I'm going to go ahead and have you guys solve this. Well, when you do, you might get no solution. Okay, if you get no solution, think about what that means in terms of them crossing. Okay, I want you to think about what that means and write it. And then I also want you to try number 10 on your own, and we'll talk about it in class tomorrow. Please make sure you take that Schoology quiz. Thanks for listening.